speak Gubi online classes for NCERT and CBSE 10th standard for mathematics and science. In the previous session of mathematics, we had covered the introduction for quadratic equation. So we related polynomials with quadratic equation, which was the very important knowledgeable content. So after that, we came across the standard form of a quadratic equation. The standard form of a quadratic equation is ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a not equal to 0. So this was the condition and c was the real constant, right? So here we have two definitions for quadratic equation. A polynomial, a quadratic polynomial, when equated to 0, it is going to become a quadratic equation, or an equation with variable, an equation of variable with degree 2 is called as a quadratic equation. So these were the two definitions. So we discussed in the previous session. So in today's session we will be entering into the most important, very important concept of quadratic equations, that is types of quadratic equations. Then we will discuss the conditions or the characteristics of a quadratic equation, and then we will move on to the conceptual problems, right? At the end of the session, you will be well aware of the theoretical background of quadratic equations, and you will be able to solve very simple conceptual problems on quadratic equations. So let us get into the session. So here, let us imagine a square. We know that in a square all the four sides are equal, okay? All the four sides are equal here. Let us call it as A, B, C, D. Let the sides of the square be x units and the area of the square be 36 square centimeters. So this is the data of the figure, right? So we have a square. In a square we know that all the four sides are equal. Let all the four sides be equal to x centimeters, and let the area of the square be 36 square centimeters. Now frame an equation using this data. This is the question it will be asked, right? Frame a quadratic equation using the given data, right? So here ABCD is a square, we know that. So in order to find the area of a square, we usually use the formula side into side. Any side into any side gives you the area of the square. So here area of square is equal to x into x, that is side into side, or side into side, or side into side, whatever it is. So area of the square value is, that is 36 is equal to x into x is x square. So if I overturn this equation, I get x square is equal to 36. So if I transpose 36 to the LHS, that becomes x square minus 36 is equal to 0. So here, according to the definition what we had learned in the previous session, any equation with a variable of degree 2 is called a quadratic equation. That was the definition what we had learned yesterday. So here also I have a equation with variable x and its degree is 2. Can we call this as a quadratic equation or not? That's the question, right? It's very simple. So here we can call this as a quadratic equation, but a special name is given to such type of quadratic equations. They are called as pure quadratic equations. So these type of equations are called as pure quadratic equations. So here, when we solve these type of quadratic equations, that is, let us solve this. So x square minus 36 is equal to 0. Let us solve it. So x square is equal to 36. We will take square root on both sides. We take square root on both sides. So square root of x square is equal to plus or minus square root of 36, right? So square and root cancels. So x is equal to plus or minus square root of 36 is 6. So here, as I told you in the previous session, if you solve any quadratic equation, you are going to get two roots. So therefore, x is equal to plus 6 is one of the root, and x is equal to minus 6 is another root. So therefore, we have two roots. So when you observe these two roots, they are equal. They are equal but opposite in sign. So whenever you solve a pure quadratic equation, here these pure quadratic equations also have two roots where both the roots are equal but they will be opposite in sign. Right? I hope you got the point. So, any quadratic equation where the variable exists in degree 2 only. Degree 2 only. What is the missing term? Which is the missing term here? So here, when you compare this with the standard form of quadratic equation, that is ax square plus bx plus c is equal to 0, you have ax square as x square, that is 1x square, and minus 36 as c, but you don't find this bx. That is, the variable with degree 1 do not exist in this equation. That is the difference you have to observe, right? So, any quadratic equation where b is equal to 0, because in this quadratic equation, b has become equal to 0. So, if b is 0, b into 0, 0 into x is 0, therefore the entire bx term vanishes. You are left over with ax square plus c only. That is, you are left with the variable with degree 2 only. Therefore, such type of quadratic equations are called as pure quadratic equations. So, it's a type of quadratic equation. It's also a quadratic equation, no doubt, but it's one of the type, right? So, what is the definition for a pure quadratic equation? How can we define a pure quadratic equation? It's very simple. A quadratic equation where the variable exists in degree 2 only is called a pure quadratic equation, right? So, next point is, when we solve a pure quadratic equation, we are going to get two roots, no doubt in that. They are equal but opposite in sign. So here you can see it is plus 6, 6 and 6, they are equal, but it is minus 6 and this is plus 6. Because plus 6 into plus 6 also gives you 36. Minus 6 into minus 6 also gives you 36. Therefore we put plus or minus sign in front of the square root of 36. That is the reason why we have to put plus or minus. You may ask me, sir, why we have to put plus or minus? Very simple. Plus 6 into plus 6 is also plus 36. Minus 6 into minus 6 is also plus 36. Therefore, square root of 36 may have, it has two values. One is plus 6, another is minus 6. So, what is a pure quadratic equation? An equation, a quadratic equation whose variable exists in degree 2 only is called as a pure quadratic equation. The roots of a pure quadratic equation are equal but opposite in sign. Right? I hope you got this. Now let us write the standard form of this. So, in ax square plus bx plus c is equal to 0. This is the standard form of a quadratic equation. So here b has become equal to 0. So if b is equal to 0, then it forms ax square plus 0 into x is 0. This entire term vanishes. We are left over with plus c is equal to 0. Ax square plus c is equal to 0 is the standard form of a pure quadratic equation. So when you find the value of x in pure quadratic equation, x gives you two roots which are equal but opposite in sign. So you can check it out here itself. So ax square plus c is equal to 0. Ax square is equal to minus c. X square is equal to minus c by a. So here x square square root is equal to plus or minus square root of minus c by a. You can do this. So square and root cancels. So x is equal to plus or minus square root of minus c by a. So therefore x is equal to plus square root of minus c by a, or x is equal to minus square root of minus c by a. So these are the two roots of the pure quadratic equation. So the pure quadratic equation has two roots which are equal but opposite in sign. So this is regarding the first type of quadratic equation. Right. Now let us get into the second type of quadratic equation. So here, to reach this type of quadratic equation, I am going to take up a statement, right? Okay. A rectangular field has its length, which is 1 more than twice its breadth. Let us take it like this. A rectangular field has length which is 1 more than twice its breadth, and if its area is 208 square centimeters, frame the quadratic equation. It's a very beautiful statement. We have to convert this into mathematics and reach quadratic equations, right? Shall we do it? So now let us take this. It's a rectangular field, it's a rectangular playground, right? This is the length and this is the breadth. Okay, the length is 1 more than twice its breadth. So we do not know the length of breadth here, so we are going to guess the length of the breadth here. So let it be x centimeters, or sorry, x meters. Let it be x meters. So here the length will be, according to the definition, the length of the rectangular field is 1 more than twice the breadth. 1 more than twice the breadth. So I hope you got it. So this is the breadth and this is the length. So the length of the rectangular field is 1 more than twice its breadth. So we have taken this, and the area is some 208 square meters. So 208 square meters is its area. So now we will convert this into a quadratic equation. Let us go with this. So in order to find the area of a rectangle, formula is length into breadth. So area of rectangle is equal to length into breadth. So area of rectangle we have it. So it is 208 is equal to length is 2x plus 1 into breadth is x. So we'll multiply this. So x into 2x, we'll take it like this for you can easily observe. X into 2x plus 1 is equal to 208. X into 2x is 2x square plus x into 1 is x is equal to 208. So 2x square plus x minus 208 is equal to 0 is the equation. We have got an equation. So if you observe this particular equation here, the variable x exists in degree 2 as well as in degree 1. It exists in both the degrees, and also we have the real constant, right? So in a quadratic equation, if the variable exists in degree 2 as well as in degree 1, then these type of quadratic equations are called as affected quadratic equations. So they are called as affected quadratic equations. So usually most of the quadratic equations where we come across in the chapter will be affected quadratic equations itself, right? So very rare we are going to come across pure quadratic equations. But if a quadratic equation, or in a quadratic equation, if the variable exists in degree 2 as well as in degree 1, then it is called an affected quadratic equation. So here, this quadratic equation also gives you 2 roots. This also gives you 2 roots. So as I told you in the previous session, those 2 roots may be equal, those 2 roots may be irrational, those 2 roots may be rational. In among those 2 roots, one is rational, another is irrational. So those 2 roots will be both negative, both positive, or one negative, another positive, something like that. It can be of anything. But strictly here, in case of pure quadratic equation, if you solve a pure quadratic equation, you are going to get 2 roots which are equal but opposite in sign. That is compulsory here in this pure quadratic equation. But in case of affected quadratic equation, there is no such restrictions. You can get any type of roots. But the roots of a quadratic equation depends upon the coefficients. That's a very different concept which you are going to learn in the coming classes. So you can guess what type of roots a quadratic equation is going to get. You can guess it by just looking at the quadratic equation, and by doing some simple steps you can easily guess what type of roots it is going to get, right? So in the previous next sessions I am going to teach you that. So this is an affected quadratic equation, right? So here no restriction for roots. 2 roots you are going to get, but we cannot guess what type of those 2 roots, right? Now, there is another type of quadratic equation. For example, ax square plus bx is equal to 0. It's also a type of quadratic equation. Can you guess which term is missing in this particular that is standard form? Here c misses. C is not here. So for these type of quadratic equations where C is not equal to 0. C is not there means C is equal to 0. That's all, right? So in these type of quadratic equations, if you want to solve it, you cannot solve it by any methods here, right? In the sense, you can in the future classes you can use formula method to solve any type of quadratic equation, no doubt in that, but you cannot go with the factorization method for solving these type of quadratic equations. What is the reason? Because it doesn't have the third term, that is C is absent. C is equal to 0. So what method is to be followed to find the roots for this type of quadratic equation where C is equal to 0? Very simple, you have to take common, that's all. Very simple, you have to take common, right? So let us take common here. So ax square plus bx, we have x as common, so it is ax plus b is equal to 0. So x into ax plus b is equal to 0 means either this is 0 or this is 0 or this into this is equal to 0. So therefore x is equal to 0 or ax plus b is equal to 0. X is equal to 0, we have got one of the root. We already got one of the root. So here ax is equal to minus b, x is equal to minus b by a. So this is another root. So please remember this is very important. It is not in your textbook. Maybe they have missed it, but for a student who has to learn quadratic equations should know this, right? So these are pure quadratic equations. A quadratic equation which involves a variable in degree 2 only is called a pure quadratic equation. A pure quadratic equation gives you two roots which are equal but opposite in sign. When we come to affected quadratic equation, the type of quadratic equation in which the variable exists in degree 2 as well as in degree 1 is called an affected quadratic equation. We cannot guess the type of roots here by just looking at the quadratic equation. No restrictions. When we come to these type of quadratic equations where C is equal to 0, the method of finding out the roots for those type of quadratic equation is by taking common. So when you take common and find out the roots, when you compare the two roots what you have got, one root will be compulsory 0. Please remember this. One root will be compulsory 0. Out of two roots, one root will be compulsory 0 and another root will be in the form of minus b by a. Another root, second root will be in the form of minus b by a. Okay, let us go with a very simple example here. I will take up an example here. 3x square plus 6 is equal to 0. Sorry, 6x is equal to 0. Here we have an equation, quadratic equation whose c is equal to 0. Let us take common. So you can take 3x as common here. When you take 3x as common, I am left over with x plus 2 is equal to 0. So 3x into x plus 2 is equal to 0. Therefore 3x is equal to 0 or x plus 2 is equal to 0. So x is equal to 0 by 3. So therefore x is equal to 0. 0 by any number is 0. Please remember this. 3 by 0 is, it's not defined. It's not defined, right? Okay. And x is equal to, x plus 2 is equal to 0. Transpose this plus 2 to RHS, you are going to get minus 2. So here, this is a quadratic equation which looks like this. When I take common, I find that among the two roots what I have got, one of the root is compulsory 0. Another root is in the form of minus b by a, that is this one. Right? So in front of you, you have three types of quadratic equations. One is pure quadratic equation, another is affected quadratic equation, another one is a quadratic equation where c is equal to 0. For such type of quadratic equation, in order to find out the roots, you have to take common. So if you take common, among the two roots what you get, one root will be compulsory equal to 0 and another will be in the form of minus b by a. I hope you got the concept, right? So this is very important. It's not discussed in your textbook, but I felt it's my duty to convince you the overall entire picture of quadratic equations. These things may come in the exams or not. I am not concerned with that. Delivering pure knowledge is my duty and I am doing it, and it's your duty to take it, right? So let us get into the simple conceptual problems. check whether the following are quadratic equations. Check whether the following are quadratic equations. Just we have to check. If it is a quadratic equation, we have to write yes, it is a quadratic equation in this form. If it is not a quadratic equation, then we have to give the reason for that. Why it is not a quadratic equation, right? So first one, x square minus x is equal to 0. Very simple. Just now I spoke regarding this. Because x square minus x is in the form of ax square plus bx. C doesn't exist. So in order to find the roots of this, we can take common method and find out the roots. So one of the root will be 0, another root will be in the form of minus b by a. Right. So x square minus x is equal to 0. So it is in the form of ax square plus bx is equal to 0. Ax square plus bx is equal to 0. So therefore it is a quadratic equation. So these type of questions you are going to get in your 1 mark question or maybe in fill in the blanks. Second one, x square is equal to 8. Right, we'll get into this. Okay, x square is equal to 8. It is not in the standard form. It's not in the standard form. So, standard form means the given quadratic equation should be in the form of ax square plus bx plus c is equal to 0. In the RHS, compulsory there should be 0. Right? And the terms and the variables in the quadratic equation should be arranged in the descending order. X square should come first, and then x to the power 1, and then constant, and then equal to 0. So this is what we call it standard form. So here it is not in the standard form. Let us take it, convert this into the standard form here. X square minus 8 is equal to 0. Now it is in the standard form. Can you guess what type of quadratic equation is this? Is this affected? No. Is this pure? Yes. It is a pure quadratic equation. So it is in the form of ax square plus c is equal to 0. This is ax square and this is c. C is equal to 0, therefore it is a quadratic equation. So particularly if you want to mention, you can mention it as a pure quadratic equation, no problem. Let us get into the third problem. X square plus 1 by 2x is equal to 0. Okay, no problem. So as I told you in the definition of quadratic equation, so a, b and c are real numbers. So here coefficient of x square is 1 and coefficient of x is 1 by 2. So 1 is a rational, 1 is a natural number or anything rational number, and 1 by 2 is also a rational number. Rational numbers are real numbers. So therefore the variable exists in degree 2 as well as in degree 1. So therefore, and also it is in the standard form. So this can be written as x square plus 1 by 2x is equal to 0. So it is in the form of ax square plus bx is equal to 0. Right? So therefore it is a quadratic equation. Right? So let us get into the fourth problem. 3x minus 10 is equal to 0. 3x minus 10 is equal to 0. Okay. So here something is missing. Right? Things what is in your mind and the things what is on the board, they are not getting tallied. Something is missing. So you are looking at the variable and the degree is 1. So therefore such type of equations are called as linear equations. So they are not quadratic equations. So it is okay as the degree of variable is 1. So therefore it is not a quadratic equation. Okay. Let us get into the fifth problem. 5 minus 6x is equal to 2 by 5 x square. Oh, something clumsy, fizzy, right? Something as it's not in the standard form. Only one word is it is not in the standard form. Let us bring it to the standard form. Very simple. Procedure is very simple. You have to look at the procedure. Very important. 5 minus 6x is equal to 2 into x square is 2x square by 5, and this has 1 in the denominator, right? So we can go with cross multiplication. 2x square into 1 is 2x square is equal to 5 into this. 5 into 5 minus 6x. So 2x square is equal to 5 into 5 is 25. 5 into minus 6x is minus 30x. So 2x square minus 30x to LHS, it is plus 30x, plus 25 to LHS is minus 25 is equal to 0. Please look at this equation. So here the variable exists in degree 2 as well as in degree 1. So what type of equation is that? So it is pure? No. It is an affected quadratic equation, right? So it is in the form of ax square plus bx plus c is equal to 0. So therefore it is a affected quadratic equation, right? So these are the problems. So I will give you homework. Just go through this, try to do this. One is root 2 x square plus 3x. Root 2 is different, x square is different. X cube minus 10x plus 74 is equal to 0. Okay. So please check whether these are quadratic equations or not. Right? I hope you are enjoying the problems. Right. Now the question changes. A little bit elaborated questions. For 2 marks you are going to come across here. Very important. Simplify the following. He asks you to simplify that. It's in the complicated form now. He is asking you to simplify and check whether the following are quadratic equations or not. So the same thing we have to do, but in the earlier steps we have to just simplify that, right? Okay. First problem is here. So here x into x plus 6 is equal to 0. So x into x plus 6 is equal to 0. X into x is x square plus x into 6 is 6x is equal to 0. It's already in the standard form. This is simplification. That's all. Opening brackets is simplification. So here the variable x exists in degree 2 as well as in degree 1. Therefore it is an quadratic equation, right? So it is in the form of ax square plus bx is equal to 0. Therefore it is a quadratic equation. That is, the variable exists in degree 2 as well as in degree 1. We can see the same variable, no single variable. That is, here x and here y, we don't find that. So right, next problem. X plus 2 into x minus 7 is equal to 5. Right. X plus 2 into x minus 7 is equal to 5. So here we have two binomials which are going to get multiplied. So we have to multiply both the binomials as per the property of distributive property of multiplication, what you have learnt in your maybe 7th standard classes, distributive property, right? So x plus 2 into x minus 7 is equal to 5. First term into first term into second term into first term into second term with sign. You have to multiply, right? Okay. X into x, first term into first term, plus sign here, plus into plus x into x, x square, x into minus 7, minus 7x, plus 2 into x, plus 2x, plus 2 into minus 7, minus 14 is equal to 5. So x square, these are the two like terms we can see there. Like terms can be added or subtracted according to the rules of algebra. So therefore minus 7x plus 2x is minus 5x minus 14. Let us take this 5 to LHS, so it becomes minus 5. Nothing is left in the RHS, therefore it is 0. Right? Again we have to simplify. X square minus 5x minus 14 minus 5 is minus 19 is equal to 0. So this is the quadratic equation, right? So now this quadratic equation is in the form of, it is in the form of 1 ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. Therefore it is a quadratic equation, right? So it may be asked for 1 mark or 2 marks. X minus 4 into 2x minus 3 is equal to 0. X minus 4 into 2x minus 3 is equal to 0, right? So two binomials again, they are getting multiplied. So very simple. So x minus 4 into 2x minus 3 is equal to 0. Let us solve this. So x into 2x is 2x square. X into minus 3 is minus 3x. Minus 4 into plus 2x is minus 8x. Minus into minus is plus. 4 3s are 12 equal to 0. So we can find two like terms here. So 2x square minus 3x minus 8x is minus 11x plus 12 is equal to 0. So this is in the form of a quadratic equation, right? So here the variable exists in degree 2 as well as in degree 1. Therefore it is an affected quadratic equation. So let us write its standard form. So it is in the form of ax square plus bx plus c is equal to 0. So therefore it is a quadratic equation, right? So we'll go with some more 3 problems and then we will conclude this session, right? Okay, I hope you are feeling it easy. X plus 1 whole square is equal to 2 into x minus 3. Very important. Let us get into this. So x plus 1 whole square is equal to 2 into x minus 3 is the given equation. You have to simplify this and then we have to check whether it is a quadratic equation or not. Okay. So here x plus 1 whole square is in the form of a plus b whole square, which can be expanded as a square plus b square plus 2 into a into b. A square is x square, b square is 1 square plus 2 into a into b is equal to 2 into x is 2x, 2 into minus 3 is minus x. So x whole square is x square plus 1 square is 1 plus 2 into x into 1 is 2x is equal to 2x minus 6. So plus 2x and plus 2x cancels. You have to be careful here. You have to look at the board. You have to be very careful. Plus 2x and plus 2x cancels. So we are left over with x square plus 1 is equal to minus 6. So x square plus 1 minus 6 gets transposed, that becomes plus 6 is equal to 0. So x square plus 7 is equal to 0. So is this a quadratic equation or not? It is a quadratic equation because the degree of the variable exists in degree 2 only. Degree of the variable exists in degree 2 only, therefore it is, what type of quadratic equation is this? Is this affected or it is pure? Yes, it is a pure quadratic equation. So it is in the form of ax square plus c is equal to 0. So therefore it is a quadratic equation, right? So let us get into the next problem, very important. 2x minus 1 into x minus 3 is equal to x plus 5 into x minus 1. Okay, very important, very important. Right. So in the LHS part of the equation we have two binomials. In the RHS part we have two binomials. We have to simplify that, then reach to the quadratic equation. Let us check whether it is a quadratic equation or not. Okay. So 2x minus 1 into x minus 3 is equal to x plus 5 into x minus 1. So 2x into x, 2x square, 2x into minus 3 minus 6x minus 1 into x minus 1x minus 1 into minus 3 plus 3. Right? You should follow this. You should follow this. You should look at the board. X into x, x square, x into minus 1 minus x plus 5 into x plus 5x plus 5 into minus 1 minus 5. Right? Okay. Right, we'll simplify the things in the LHS. So 2x square minus 6x minus 1x, they are like algebraic terms, we can simplify them. So they become minus 7x plus 3 is equal to x square. Simplify these two, minus 1x plus 5x. Nothing is there. No numerical is there with the x, means it is, the coefficient is 1 actually. So minus 1x plus 5x is plus 4x minus 5. So let us transpose these three terms to LHS and make RHS equal to 0. So 2x square plus x square comes here, it becomes minus x square. This minus 7x I will write, plus 4x comes to LHS, it becomes minus 4x, plus 3 I am going to write, minus 5x comes here, that is plus 5 is equal to 0, because all these terms are in the LHS, therefore RHS becomes equal to 0. So 2x square minus x square is x square, minus 7x minus 4x is minus 11x, plus 3 plus 5 is plus 8 is equal to 0. So this is the required quadratic equation. So the variable exists in degree 2 as well as in degree 1, therefore it is, I can call it as an affected quadratic equation. So it is in the form of ax square plus bx plus c is equal to 0. So therefore it is a quadratic equation. Right? Okay. Let us get into the sixth problem. It is x plus 2 whole cube is equal to 2x into x square minus 1, and seventh problem is x minus 1 into 3x minus 1 is equal to x plus 7 into 3x minus 11. Right. So these two problems, please do it as a homework. Apply a plus b whole cube formula here. A cube plus b cube plus 3ab into a plus b, what you have come across in your lower classes. So it is a plus b whole cube is equal to 2x into x square minus 1. So maybe cubes are going to get cancelled. Maybe you are going to reach to quadratic equation. Maybe not. No, I don't know, right? Solve it, then please check it out. So solve this one also, send it to me through the WhatsApp, right? So I hope in today's session you have enjoyed all the problems. So in tomorrow's session we will be going with the same problems of different types. We will be going with that. So don't worry about the cutout syllabus, right? Learn the concept very well. Here your higher classes, that is your PU classes, are very important. Without basics in your SSLC or in your 10th standard classes, it will be very difficult to cope up with the PU syllabus. Please learn the basics, fundamentals very clearly, right? So with this, I would like to conclude this session. Stay home, stay safe, and keep learning.